We are starting from section 4 today. We're starting from section 4 today. Your test, which is on the 13th, will include the entire chapter though, right? So 2.1 to 2 point whatever, 6 or whatever, like for the whole chapter. Okay. Right, so this whole chapter basically is stuff that you've been introduced to last year, but we're just building on it this year. So let's talk about polynomial functions a little bit more. Let's talk about zeros of polynomial function. So if a polynomial function has a degree of n, then it can have at most n real zeros. And those n zeros can either be rational or irrational, right? So a zero of a function can be 3 and negative 3, or it could be root 2 and negative root 2, right? The rational zero theorem provides a way to determine a list of all the possible rational zeros of a function. So basically, you have some, weird function, x to the power of 7, blah, 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 blah. And then you have to find the zeros, right? So one way is you can sit there and try every single integer until you get one that gives you a 0. That's a silly way to do it. There is a way to narrow the list down. If that function had rational zeros, 1, 2/3, negative 4, negative 6 over 7, these are all rational numbers, right? This theorem will give you a list, right, so that any rational zero will be within that list, okay? So the way we do it is this. It's this process where you determine a value for P and a value for Q. Did you guys do this, P over Q, before? Okay. And so when you divide P and Q, you get all of these numbers. So where do these mysterious P's and Q's come from? Well, P is a factor of the constant term at the very end. Q is a factor of the leading coefficient. Okay? And then you do P over Q. So let's do this then. So list all possible zeros of this function. It just says to list. You're not going to do any solving. So here's what we do. This number here, okay, is used to find P. And what's the leading coefficient here? 1. The leading coefficient is 1. That 1 is used to find Q. Okay, so for P, you have to use all of the factors of 4. So what are the factors of 4? Back from when you were in like elementary school, right? 1 and 4 are factors of 4, and 2 and 2. So 1, 2, and 4. But what about negative 2 and negative 2? Yeah? What about negative 1 and negative 4? Yeah, so all of those as well. So we do plus or minus in front of each of them. Yep. I know, it's like a brand new world. And then for Q, what are the factors of 1? Plus or minus 1. Okay, so those are all the values for Q. Now what you're going to do is you're going to do P over Q, meaning you have to take each of the P's and divide them by each of the Q's. Okay, when this is a 1 and Q is just plus or minus, that's the best case because you just get these numbers repeated, right? Like you just get 1 over 1, 2 over 2, 4 over 4. And so it's going to be 1, 2, 4. Technically, they're all plus, minus, plus, minus, plus, minus, but because it ends up being like so much unnecessary like writing, I will allow you to do this, but please don't forget, okay? So that's it. This is the answer to this problem. What is this now? This is the list of all the possible rational, right? So this is the list of all possible rational zeros of this function. So for example, function had a rational zero, it has to be one of these 6 numbers. So we know that -3 can never be a zero of this function. 1/2 can never be a zero of this function because it's not in this list. Do you see that? So that's all this says. It's kind of cool. And you know, I thought I wasn't going to skip this, but I am. I'm going to skip Descartes' rule of signs. Sorry, Descartes, I love him, but Descartes, he's the guy who said, I think, therefore I am. Yes. He was a philosopher and a mathematician. French, René Descartes. Yes. Back in the day, everybody was both a philosopher and a mathematician. Now it's so like weird, right? Like it's like they're exclusive of each other. But back in the day, you know, I guess they were just the thinkers overall. Anyway, okay, complex zeros. Okay, fundamental theorem of algebra says, okay, so this is the fundamental theorem, so you know it's like a thing, right? Okay, FYI, in case you're ever on Jeopardy, you need to like give me on-air credit for this. There are 3 theorems in math that are fundamental theorem of. This is one of the 3. There's fundamental theorem of arithmetic, fundamental theorem of algebra, and fundamental theorem of, like in calculus, so fundamental theorem of calculus, FTC. So FYI, okay, it's a good trivia fact to know. Okay, so here's what this says. A polynomial function of degree n has at least 1 0 in the complex number system. That's it. That's all it says. So there is no function that has no zeros. Every function has at least 1 0. It could be an imaginary 0, but it still has one. And as a corollary, whatever the degree is, the function has exactly that many zeros. It's just that some might be real and some might be imaginary or complex. Okay? All right. So, linear factorization theorem. These are all like theorems I'm throwing at you, but then we're going to go through them. It says a polynomial function of degree n has n linear factors. Okay? All right. So, here's another term for you. A function, so it's possible for a function to have complex zeros. How do you get a complex zero? So like if you factor, suppose you factor a polynomial equation and you get, I don't know, x minus 1, x plus 4, x squared plus 2, right? Okay, this is a degree of 4. It's got to have 4 total zeros. This is a 0 of 1, -4. Well, what about here? What do you get from here? What zeros do you get from here? Plus or minus x equals plus or minus I root 2. You guys remember? Okay, so you get I root 2. We'll go over this again. So look at this. You have 2 imaginary zeros, 2 real zeros. Okay? Where did the imaginary 0 come from? It came from this. Is this a linear term? It's a quadratic term. Can we factor this like we can factor the other 2? No. This is called an irreducible quadratic factor right here. Irreducible, because it can't be factored, quadratic factor. Okay? All right. So, let's now do one. Look at this beautiful function k of x. Isn't that beautiful? Right? This is why I love Precalc, is because it's no longer x squared plus 3x plus 4. Like, those are so boring. Look at this, right? Okay. So, write kx as the product of linear and irreducible quadratic factors. So basically, this is just telling you to factor. Okay? All right, so here's what we're going to do. First, we're going to do p over q. Now, for p, we're going to use the 24. For q, we're going to use what? 1. And remember 1, that's the best case scenario, right? That means p over q is just the values of p, right? So, P over Q is plus or minus. Okay, so here's how I do the factors. I do it methodically from 1 and up. So 1 is a factor, and then I go up. 2 is a factor, so is 3. 4 is a factor, 6 is a factor. And now once like you start pairing up, see, like with 6 you're pairing up with the 4. So now the other one has to be the pair of the 3, which is 8, 12, and 24. Okay, so one of these is definitely a 0 of this function. So we had an infinite number of numbers. Now we only have 2, 4, 6, 8, 10, 12, 14, 16. So what we're going to do now, we're going to try each and every single one, synthetic division, and see which one works. It's like, you know, it's like the lottery. Like you either you can get on the first one or it can be the very last one. You know, it's like the lottery. It's very time consuming. I get it. So I'm going to cheat a little bit. I did it before. And wouldn't you know it, -2 is a factor. So we're going to start with -2, and then I'll show you guys how to do it quicker. You have to try every single one. You have to do synthetic division with every single one until you get one with a remainder of 0. And it's a lot of unnecessary wasted time. That's why I'm going to cheat, and I'm going to tell you the first one is -2, and then I'll show you guys how to, okay? Okay. So -2, huh?
We're going to have a faster way of doing it.
Yeah. Okay, but this, once you get the -2, like that's not going to change anymore. Okay, so here, remember synthetic division? Are all the exponents here? 5, 4, 3, 2, 1, 0? Yes, so 1, 1, -13, -23, -14, -24. Okay, 1, -2, -1, 2, -11, 22, -1, 2, -12, +24, I get a 0. Okay, fabulous. So what does this mean? This means that I can now write kx as x plus 2 from the -2 on the outside, right? And then remember how these are now the coefficients of the new polynomial? So whenever you do synthetic division, the degree gets reduced by 1. So it's x to the 4. So now it's going to be 1x to the 4 minus 1x cubed minus 11x squared, and so on. So x to the 4 minus x cubed, 11x squared, x minus 12. Okay, so this is not factored at all. So guess what? I got to do it again. Now there has to be another one that works, right? But when I do it again, I'm just going to do it on this polynomial. So it's going to be 1, -1, -11, -1, -12. Okay, which of that list works? Well, 4 works. Okay, 1, 4, I'll tell you. 3, 12, 1, 4, 3, 12, 0. Okay, now let's write kx again. So we had x plus 2 from before. Now I have x minus 4, x cubed plus 3x squared plus x plus 3. Oh my God, I love this stuff. Like, you have no idea how exciting this is. Okay, now we have a cubic term. Once you get to a cubic term, it's possible to actually factor by hand. And then if it's not possible, then you have to do this again. My go-to is factor by grouping, right? And there are lots of ways to know whether you can factor by grouping. Basically, the easiest way is, like, if you see that there's a pattern in the coefficients, like 1, 3, 1, 3, then you know it's possible to factor by grouping. My advice to you is always try to see if you can factor by grouping. So to do that, we're going to split this up. So first of all, this is going to be x plus 2, x minus 4, And then now I'm going to just work on that last term. You split that up. From the left side, I can factor out an x squared, and I get x plus 3. Plus, from here, this is 1 times x plus 3. Okay? So let's go up here. I'll keep the colors the same. Okay, so you see how in the red you have a term that repeats, the x plus 3? Write that off to the side. And then what do you have remaining? X squared plus 1. Okay, can you factor this further? No. We're done factoring. So now I ask you, in your wildest dreams, did you ever think if you had a function like this, you'd ever be able to factor it into this? Like, look at this. Look at why math is so beautiful. Do you see it? How come you're not as excited about this as you should be? Like, do you see how exciting this is? Like, never in your wildest dreams could you ever have done that before. So here we go. Have we answered the question? It says write kx as a product of linear and irreducible quadratic factors. Linear and irreducible quadratic factors. So that's it. We factored. Okay? All right. So that's the answer. Okay? Now, okay, now B says, you know what? No, that's not good enough. You have to get rid of that quadratic factor. Now, write it as just a product of all linear factors. Okay, fine. Linear, 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 linear. This is the one that's a problem. So how can I factor that so it's linear? So let me tell you this. Why is it impossible to factor this? It's because of that plus in the middle, correct? But if that was a minus, I could have factored that, right? So let's change it to a minus. Can I rewrite that as x squared minus minus 1? Can I? Yeah, why not? So that would look like that, right? Now, if I had a function like this, oops, sorry. How do I factor that? I take the square root of the first one and the square root of the next one, and I do plus or minus, correct? Okay, so if we could do it to that, why can't we do it to -1? Like, what is that? Like, that doesn't have, like, it's not less of a number, right? So let's do it to that one. So here we go. The square root of x squared, and then plus minus. What's the square root of -1? I. And there we go. You see how we can factor it? So nothing is impossible. Well, many things are, but most things are not. Okay? Okay. So now kx is x plus 2, x minus 4, x plus 3, x plus I, x minus I. There we go. Okay? So, what are the zeros of kx? Well, it's -2, 4, -3, and plus or minus I. Okay? So remember, the imaginary numbers will never exist alone. They always come in pairs. Okay? So how are we going to do this if you don't have me to tell you what the initial starting point is? If it's a portion on the test where you have your calculator available, you're going to just graph that function. Okay, you don't have to take your calculators right now. I can show you. If you don't have your calculator available, I will give you a starting point. I will say factor blah, 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 given that x equals -2 is a factor. So you know, or a 0, so you start from that. Does that make sense? So I'll give you a point. I'm never going to ask you to just like blindly do them because it does take a long time, okay? And there was a time that I used to ask students to do that, but since then, like, you know, like that was the norm for everybody, and now we've changed things. Yeah.
So So when we did it the first time, you gave us the first one. How did you figure?
That's what I'm telling you right now. That's what I'm showing you right now. So, so basically, what I want you to do, if you have this problem, I just want you to factor it. I'm sorry, plug it into the calculator and graph it. So you get x to the power of 5 plus x to the power of 4 minus 13x to the power of 3 minus 23x squared minus 14x. Okay, graph this. Do you see all the zeros? Where are there zeros? At -3, -2, and 4. So just pick one of them. I happened to pick -2. Okay, why did I pick -2? Who knows what I was thinking at the time that I picked it, but I picked -2. You could have easily picked -4. The process will have looked different, but the answers will be the same. Does that make sense? So you pick -2, you do this, and then you're like, oh wait, I need another one. Okay, go back to the graph, now choose another one, okay? You have to not skip any of this process though in order to show me the work. Remember, in Precalc Honors and moving ahead, it's not about the final answer, it's about the process, right? You can all graph something and get the final answer. That's not the issue here. Yeah. Oh, any questions? Yep.
So on the test, you'll give us the first one?
Yeah, I'll give you enough to get to like start and continue. Okay? All right, and then if it's a calculator section, you can just graph and do it yourself.
But then how would we know where the I is?
Oh, you have to do that. So the I you have to know. Because you see how like I factored, and then I got this term. Now you have to do that same process for that and do it. So the I won't show on the graph. You have to do it yourself.
But how do we know if it's not?
If you have an irreducible quadratic term,
Like how do we know from the graph?
oh, you can't. Not from the graph, but you have to know from here. Yeah. Okay. All right. So, well, I mean, I guess you can know because it's x to the 5. So you should have 5 total zeros, but on the graph there was only 3. So you know there are 2 more which are imaginary, but you don't know what they are. Okay. Write a polynomial function of least degree with real coefficients in standard form that has cube root of 5 as a 0. Okay? For this, we're going to go backwards. If it told you 5 was a 0, right? What would the term look like from which you get 5 equals 0? It would just be x minus 5, right? Yeah? Okay. And then how would you get, so x minus 5 gives you x equals 5. X squared minus 5 gives you what zeros? Plus or minus root 5. But now I want the cube root. So do you see how this index matches that power? So if you want a cube root, that means f of x is going to be x cubed minus 5. That's it. Yeah? Not too bad, right? Okay, next one. Write a polynomial function of least degree with real coefficients in standard form that has these as a 0. Okay? So we have -1, 2, and 2 minus I. Now, you're only going to be given one complex 0, but you have to know that complex numbers always come in pairs. So it always has a buddy, and the buddy will be the conjugate 2 plus I. So f of x is going to be x plus 1, x minus 2, and x minus 2 minus I, x minus 2 plus I. So basically it's x minus each of the zeros. Okay?
If they put the 2 minus I, it
Yeah. Yep. Okay. Now, there are two different ways of doing it. Depending on how you know what, I'm going to show you the second way this year. I don't know. I'm just switching things up this year. Okay. Okay, so this, that's like, what? Like, it's so old school now, right? Like, we used to do it when? What? Like, 3 years ago you learned how to do that? So what does that give you? X squared. Okay, that's so like 2 years ago. Okay, here. Oh, you know what? I am going to distribute this. Okay, so here's what you have to do. You have to distribute this negative. So now you get x minus 2 plus I, x minus 2 minus I. Now, back in the day, you learned the associative property, okay? And it's such a stupid way of teaching kids because nobody ever uses it and nobody ever thinks, when am I going to use it? So basically, the associative property says a plus b plus c is equal to a plus b plus c, like this, right? It's so like out of context when you learn it. Here is where you use it. Basically, this says if you have 3 or more things, you can group them as you wish. So here, we can group this as we wish, and guess how we're going to group them? Like this. Okay? Now, do you see how both of these brackets have the same term, plus or minus the same term? Is that like a minus ba plus b? Yeah, but a complicated version. So this is a, b, a, b. So here's what we're going to do. This stays. And then here, how do you do a plus b, a minus b? Like if you have this, how would you do it? You square the first term, you square the second term, you add a minus in between. Okay? Yes? Let's do it. Square the first term, square the last term, minus in between. Is I squared negative 1? Yep. So this is going to be x squared minus x minus 2. And then here you're going to get x squared plus 4x minus 4. Do you guys remember the, I'm sorry, minus 4x plus, do you guys remember the shortcut I taught you for this? And then here, plus 1 for the I. And then you have to distribute this further. Okay? So it's x squared minus x minus 2, x squared minus 4x plus 5. This is f of x. But you have to put it in standard form, so you have to multiply this out. I'm just not going to take time to do it right now. Is that okay? You guys know how to do that part, right? Yes? No? Yes? Basically, distribute x squared to everybody here, negative x to everybody here, negative 2 to everybody here. Can't remember? Come ask me. Do you guys remember? Okay.
Is I squared negative 1 or
Negative 1. Because I is the root of negative 1 squared. I'm sorry, it's the square root of negative 1. Okay. Finding zeros when 1 is known. So it's possible to use synthetic substitution for this as well. So how do we do this? Write a polynomial as the product of linear and irreducible quadratic factors. Okay? So you take this, and this should have like a y in front of it. But basically, if you take this and set it equal to 0, what do you get? X cubed is root 3. Ugh. X cubed is 3. X is cube root of 3. Right? So the problem is now we have to factor this. But what the heck? You've never had to factor something like this. So how do we do it now? Well, synthetic substitution. Same idea as before. Get 1 0 and then do synthetic division. So here's the 1 0. And then what coefficients do I put here? 1, no x squared, so 0, 0, 3, negative 3. 1 comes down, cube root of 3. Okay. Now we're gonna multiply cube root of 3 times cube root of 3. That becomes cube root of 9, right? But I can't do anything else with that. Multiply again, I get cube root of 27, which is how much? 3. Oh, wait, this should have been a negative 3, sorry, when I moved it over. Okay, so what do we get here? 0. Should I have gotten a 0? Yeah, because it's a 0, right? That's how I started. So now, let's write this out. So y is x minus cube root of 3 from the outside times. These are now the coefficients of the new polynomial. It was x squared first, now it's x cubed first, now it's going to be x squared plus this times x plus this, okay? So, x squared plus cube root of 3x plus cube root of 9, right? So the idea is nobody ever said the coefficients of a polynomial function had to be a whole number, right? Yeah.
How did we get the 1, 0, 0, negative 3?
So you have to put the coefficients of this here, but you have to put zeros for any missing terms. Okay, last but not least, okay. So here's how like something might look on the test as well, right? So find the complex zero, find all the zeros of this, given that 2 plus 5i is a 0. Okay, so if 2 plus 5i is a 0, so is 2 minus 5i. So let's do this. We're going to put 2 plus 5i out here, and then we're going to put the coefficients, but spread them out because this is going to take a little bit more space. So 1, negative 6, 35, negative 50, negative 58. 1, 2 plus 5i, right? When you add this, what do you get? Negative 4 plus 5i. Okay, now here we have a little bit of like mundane calculations. You have to multiply 2 plus 5i and negative 4 plus 5i. So what does that give you? Negative 8 plus 10i minus 20i plus 25i squared, right? So it's a little bit of calculation. So this is negative 8 minus 25, negative 33. Do you guys see how I did that? So here we get negative 33 minus 10i. Yeah? Now I add, so I get 2 minus 10i. Okay? So now I have to do it again. So I have to do 2 plus 5i, 2 minus 10i. You have to FOIL it. And so you get 4 minus 10i plus 50. That's 54 minus 10i. There is a little bit of a satisfying nature when we do the other one, I promise you. So 4 minus 10i is what I get. And then 2 plus 5i, 4 minus 10i, it's like black magic. You get 8 plus 50, 58. So you get 0. Okay, this looks like nothing we can use. However, there is another 0, isn't there? What's the other 0? 2 minus 5i. So now we're going to do the same thing with 2 minus 5i, but we're going to use these coefficients. 1, negative 4 plus 5i, 2 minus 10i, and this. Okay, this is the satisfying part. 1 comes down. Multiply, you get 2 minus 5i. When you add, what do you get? Just negative 2. The complex part disappears. Multiply, negative 4 plus 10i. Add them, negative 2. Multiply negative 4 plus 10i, you get 0. Okay? So, I got less than a minute. So what do we do now? What's this polynomial going to give me? Originally I had x to the 4, got reduced to x cubed, got reduced to x squared. So this is x squared minus 2x minus 2. Okay? And we have to find the zeros, right? Okay, you can't factor this. So you have to use the quadratic formula. Negative 2 plus or minus b squared minus 4 ac over 2a. So this is 2 plus or minus root 12 over 2. What's root 12 when you simplify? No. Yeah. So this will be 1 plus or minus root 3. Okay, so what are all the zeros? 2 plus 5i, 2 minus 5i, 1 plus or minus root 3. Oh, what a problem. All right. We made it just in time.